Hello and welcome to Gotham Sound TV. I am very excited to be bringing you an episode about the Sennheiser Spectera system. I am talking to Chris Phillips, Technical Applications Engineer from Sennheiser. Hi, Chris. How you doing?
Hey, Peter. Thanks for having me.
Oh, yeah. Thanks for joining us. A couple of things. We're here to talk about Sennheiser's WMAS system. And am I saying that right? Spectera?
Yes. Yep,
Okay.
that's it.
So it's the Spectera system. And I think a couple of things for those that are tuning in. First of all, we're live. So ask your questions for Chris. Definitely I can already see the questions coming in. I love that. So yeah, definitely ask them. I will get to them. And I also want to say I'm skewing this live stream a little bit towards Gotham Sound's core customer base, which is location sound for film and TV, and also with an eye towards specifically broadcast news, operations like studio operations, and we'll explain why. I'll explain why as we go through the presentation. But to give context, and then I promise I'll turn it over to you, Chris. I look at WMAS not as a specific product or even a specific group of products, but more along the lines of a whole new kind of wireless technology, almost akin to, like the first early wireless mics were analog FM, and then digital radio mics came in. And just like there isn't one, monolithic digital radio mic system that all the manufacturers make, so too there is not one monolithic WMAS system that all the manufacturers will make. This is more of a kind of protocol or a framework for wireless systems. Even within WMAS, I'm learning, there's different modulation schemes possible. So I think, having said all of that, and if you're still watching, I'm really happy that you're all watching. Chris, I'm going to turn it over to you.
Okay, sounds good. And thank you. We'll talk about the road that got us to where we are today with recent new regulations for WMAS, which stands for Wideband Multichannel Audio System. So the goal for this would be multiple channels in a carrier. And that's what we were shooting for. More channel density, more efficiency with the spectrum becoming more compressed and more compacted. We really want to leverage multi-channel systems with this technology.
So that's the first thing that differentiates this technology, whereas FM technology and digital radio mic technology as we currently use it, that's one carrier or maybe two carriers, two audio paths per carrier. One audio or two audio paths per carrier, whereas right now with WMAS, there's a lot more density that we're talking about.
Yeah, we have more flexibility, and actually they're in the regulations for a WMAS system, you have to have multiple channels on that carrier. So narrowband systems, so 200 kilohertz. If we look at where we started, which was 1957, we released our first wireless microphone system. They're usually a transmitter to a receiver, and that's going to be one mono carrier for a microphone or a stereo carrier. For a stereo IM feed, we could do that over a narrowband carrier, and we've been working with that 200 kilohertz regulation since the beginning of this. And so we started with analog narrowband. There's no real measurable latency on analog narrowband, so it's great for low latency applications. In 2012, and this is the Sennheiser path, but right around this time, wireless microphone manufacturers and other manufacturers of PMSC wireless began to create digital narrowband systems. So this was around when our D9000 series came out. And we were able to use different codecs and different transmission schemes. D9000 was even able to do, PCM audio if you had your antennas just right and the noise floor was just right. So there was a lot of work that went into that. So it was difficult on a digital narrowband system, but we're still innovating on those. So all the manufacturers, even with, this kind of new landscape of WMAS regulations where we can do more things with a PMSE carrier. We're still innovating for narrowband systems, and I think you'll see that from all the manufacturers. But with that 200 kilohertz bandwidth, there's only so much you can do in that carrier, and we're really, innovating on the edges more than what we can do with a wider band carrier. We started thinking about, if the regulations weren't 200 kilohertz in 2013. And this year, in February, the FCC passed a regulation which allows these systems to be possible. It was already approved in Europe before that, and now we're seeing countries globally start to write their own standard regulations for WMAS. But WMAS, as you said, I think framework is a good word. We are able to build within the new WMAS framework. We're able to create systems that meet those regulations.
And that's sort of the key takeaway right now, is that this is a framework for allowing multiple, not just audio paths, but multiple points of data and telemetry in a single carrier.
So we kind of look at the road. We looked back in 1957, 2013. We started doing research projects around, wideband technology. 2016, we started working on the regulatory side, and this was approved as a project. We had our first prototypes in 2014, 2015. It was approved as a project in 2018. And that's when we really put the first proposal to the FCC. And other manufacturers did join us at that point in time to allow us to kind of break away from that only 200 kilohertz framework. Very recently, we've been working on this for a long time, with the first thought bubble popping up in 2013. But we are now able to bring these products to market and these technologies to market as of this year. So it's taken a little bit of time. Here's what the FCC regulation says. So this is what was passed on February 15th and allowed. We can do 50 milliwatts up to 200 kilohertz unlicensed. So that is what we typically have for the narrowband carriers. If you have a Part 74 license, you can have more power than that. But for most users, 50 milliwatts for up to 200 kilohertz. And then that stays the same up to 1 megahertz with the WMAS carrier. And we can go up to 100 milliwatts, which is interesting. We petitioned for 50 milliwatts, but they gave us 100 based on needs from other manufacturers. So this is great, 100 milliwatts up to 6 megahertz wide. So a standard DTV carrier. And that's allowed. Up until then, we had a couple secret meetings with the product, and Peter was at one of them in New York, where we had to get an STA, so a special transmission authorization to transmit with this system in the US. Now we don't have to do that. An unlicensed user can use this system 100 milliwatts up to 6 megahertz wide. And so that's kind of the framework in which we develop. And then, so that's the WMAS regulations. Spectera would be Sennheiser's interpretation and our first development to work within this framework. So when we talk about WMAS, it's kind of the broad framework, and then manufacturers are going to take different creative ways to build products within the new framework.
And so I think the natural question would be, 6 megahertz wide carrier, holy crap, how do you possibly, that takes up, the whole spectrum. How does that work? Which I think might be coming up in your presentation soon.
Yeah, actually, that was like that's teeing me up pretty good as to why we did 6 megahertz, but you don't we have a solid reason for that, and a lot of that is channel density and bidirectionality, but also how that carrier behaves with multipath and fading.
And just a quick aside for our international friends, this is licensed worldwide, so internationally in a 8 megahertz channel wide country that we'd be talking 8 megahertz.
In Europe, yeah. And when we use these carriers, we have to stay within the TV grid.
Right.
So if you were looking at a frequency scan and you were finding space between DTV channels, or when we talk about 6 megahertz, where am I going to put that? In almost every market, the unlicensed part of the duplex gap, the system works in that spectrum just kind of as part of its range. That's widely open everywhere, so you can use it there. So that's a good starting point, where you would have the ability to operate 6 megahertz there. The reason we do 6 megahertz wide, and this is our design philosophy on it, not everybody's going to agree on this, is because of fading due to multipath. This is a pretty busy slide, so I'm going to pause it because it looks like Vegas mode when it's running. But we're just gonna pause it at one point in time randomly. And what we're looking at here on the left side is 10 wireless microphones that are narrowband. So each of those colors is a narrowband wireless microphone. On the right side is a WMAS carrier that has all of those channels of audio in that carrier.
Right.
We know that up to 2 megahertz wide. So phase cancellation due to multipath, within our company, and it's maybe a more European term, we call it fading. But multipath phase cancellation can take a notch out of an antenna signal up to 2 megahertz wide, which can be pretty catastrophic. And that's why we have to be really intentional with how we do diversity systems.
In my experience, the most extreme time I've experienced multipath reflections and phase cancellation cooking reality shows where you just have all of the stainless steel appliances and just bouncing, everything is bouncing around, and you really need to think about where your diversity antenna is so that as the contestants move around the kitchen set, one antenna always will see a signal. And so if I understand this diagram correctly, we're looking at the RF level from one antenna.
There's two. So there's a blue line and a silver line.
Got it.
And we can see that, on antenna B,
got it,
had a pretty catastrophic fade. In the middle of the WMAS carrier, we also had a very narrow, catastrophic, phase cancellation here. Which on that narrow band carrier, and this can be, like I said, wide, up to 2 megahertz wide.
Yeah.
You can get some catastrophic fading, and that's why we have to have the A antenna and the B antenna, or we have to really, jack the power up to get enough carrier to noise ratio to overcome these fading losses. So when we look at, and this is our approach to it, if we have a 6 megahertz wide carrier, we're using a technology which they use in digital television called OFDM. So we are subdividing the 6 megahertz carrier into hundreds of subcarriers, and each one of those subcarriers has all of the data stream on it. So we're kind of building redundancy across the carrier for all of our audio links that are going back and forth. When you have a catastrophic fade like this, the information is still going by. So it's like a 12-lane highway. If two of the lanes get taken out in the middle of it, the cars are still just going right around them, where that can't happen in a narrow band system. So that's why we approach it this way. What we know is by measuring it, by testing it, by doing MATLAB calculations, is that one antenna with the 6 megahertz carrier is equivalent to 30 times diversity of an antenna in a narrowband carrier. If you bring that carrier to be narrower, you have to, compensate by using more antennas, so you have, a wider diversity scheme, or a more a more than a more point diversity scheme, and that has to be your safety there, or you have to bring the power up higher.
And so this addresses one of Martin Schulte's questions: how can the 3040x diversity comparison be explained in layman's terms? Which, if I understand it correctly, by making the carrier 6 megahertz wide and having redundant data streams within that 6 megahertz carrier, a multipath phase cancellation would only affect 2 of the 6 megahertz, and the other data is contained in the other 4 megahertz. Is that fair to say?
That's accurate, and that's what we see in this spectrum. We can see those fading notches be up to 2 megahertz wide, and so that's why we approach it this way.
And this is just my curiosity. The fading notches being 2 megahertz wide, does that change with the carrier frequency? Is that a function of the carrier frequency? Like, in other words, the higher the carrier, the shorter the notch, or is there any correlation?
That is variable across the whole spectrum. What we see in the broader UHF spectrum, across that 470 to, if we're in the duplex gap in the mid 600s, we will see those wider fading notches.
Got it. Okay, good.
And then another part of this carrier, if we look at the other side of it, is once we stack mini narrowband carriers next to each other. So this example shows 9 50 milliwatts narrowband carriers. On the front end of a receiver, that becomes additive. So that RF power is received, within the filter set of a front end receiver as 450 milliwatts. When we do a 50 milliwatt, 6 megahertz wide, or WMAS carrier, the 50 milliwatts is spread across the carrier and it's less impactful. What that means is we can reuse it easier. So like when there's different interpretations now that this is out there of how a system can be polite. Our definition of it being polite is that we can use it in adjacent spaces, like with structure in between. So the frequency becomes more reusable if it's a film lot and you're shooting in buildings next to each other. If it's a Broadway scenario where there's theaters next to each other, we can reuse the 6 megahertz more often than you can with a narrower, higher output carrier.
I see. So by keeping the total power at any one point in time to 50 milliwatts, then it's just 50 milliwatts that you're trying to contain in a single area. And you can more easily reuse that in adjacent spaces. I think this starts to get into Carlos's question about how would a WMAS operator, Spectera or other, affect narrowband operators in close proximity? Will they be good stewards of the shared spectrum? And I think certainly this in part accounts for that. I think there's other ways that we'll get into and other interference mitigation things that we'll talk about with Spectera specifically, but this is one of the ways that answers Carlos's question, I think.
Yep. Yeah, exactly. So this system is the first bidirectional digital wireless system. It has the ability in 1RU to do 32 in and 32 out, so up to 64 channels of audio. And the devices in the system are all transceivers. So this is the first mobile device, which is, we call it the SEK pack, which has both a microphone input, so a 3-pin LEMO mic, and a impedance matching headphone preamp. You can use them both at the same time.
And I want to emphasize a word you said there, which is first, because this presumably is the start of a generation of products. Good.
Yeah, this is, we switched with D6000 into a development framework called Agile, from more of a waterfall framework. Software developers know this pretty well, and other engineering terms. So our goal with this is to get, our base system out into the market, like our ecosystem with the base station, the antennas, our first mobile pack, and then the one that's already on the board to get done as quickly as possible is a handheld. So that's going to be coming shortly after. And then from there, we wait for the market to tell us what to build. And then we keep the development team intact.
Right.
So this is kind of the start.
So Andrew's question right now, can the belt pack transmit in stereo? I think
Transmit in stereo, not this one can't.
Right.
Yeah, so like stereo microphones.
Right.
But we could make a device that does that within the ecosystem, whether that be a plug-on or a body pack. That's something that's been tossed around and is an idea right now.
Good. No, that's, I think, definitely the kind of example for that. Okay, so the pack itself is a right now that pack can do two things: transmit and receive. It'll receive in stereo. Is that correct?
It could receive in stereo, so it's two. And we'll talk about how you roll this out. But we're using a TDMA scheme, so our data stream, and we talked about how that data stream is kind of chopped up a bunch of subcarriers for OFDM across the 6 megahertz.
Mm-hmm.
Look at the stream, it's 128 time slots. And then and it's bidirectional. So the IEM or IFB side and the microphones share the same 6 megahertz carrier. And as we stand up audio links, whether that's a microphone, an instrument, you can do that on this too, or a IFB or an IEM, each one of those audio links takes up some of those 128 time slots. And then we have different modes or audio link modes, we call them, which if you need a 96K lossless PCM audio at 1 millisecond, you could do that. Or if you are okay with 9.9 milliseconds, but you need longer range, you can do that. And each one of these modes will take up more or less time slots and more or less of the resources in your 6 megahertz carrier. So the microphones and the IFBs, they share the 6 megahertz, so we get channel density. Right now with narrowband systems, it's not a good practice to coordinate your IEMs and your microphones on the same 6 megahertz block. Sometimes you do what you got to do when you're a frequency coordinator, but it's not the best idea.
Right.
So now we can get channel density with this as well, and also get, but yeah, for the stereo, that takes up 2 of your audio links. It's a pure stereo, 2-channel stereo. We're not doing a companded, trying to squeeze everything
FM
down on
module.
Yeah.
Yes. So I just want to take a pause here, because I think this is a huge idea that what Spectera is doing. Each element in the system, and Chris, correct me if I misunderstood this, each element in the system transmits at the full 6 megahertz, but only in its very narrow, specific allotted time slot. Yep. And there is presumably the transceiver, which you had a specific word that you guys are calling it, the antenna?
We call the antennas, they're directional audio, digital audio directional antennas. So we call them DADs.
DADs. Okay. DAD. Well, then what I'm about to say, it might be is very old fashioned, but the DAD is sort of coordinating the timing for everybody. So each pack, so all the packs don't try and transmit at once. Is that also accurate?
The base station is.
The base station.
This one RU box is the brain of everything. The DADs, and when we get into this, we'll take a look. All of the RF transmitting and receiving and all of the RF components are at the DAD now. So we're running category cable to the DAD, and that's all happening here. But the base station, once you set that audio link mode for your IEMs or for your microphone on each device, and even in the pack, those are purely independent settings. So you can have a higher latency IFB with a very low latency, microphone if you want to. They're all independent of each other. The base station is determining what's in each time slot, and each one of those frames is flying within nanoseconds. I mean, it's very, very fast, the refresh on it.
Right. Okay, and so I'll get into those. We'll talk about specific latency questions in a second, but I also want to reiterate something that you said, which is that, first of all, there's no coax in this system.
No.
Right, so it's Cat5 or better cable to the DADs, and the DADs are your transmit and your receive antenna. So there's now just one antenna per zone, because as we talked about in the previous slide, we're not worried about diversity antennas for multipath cancellation. We may want to add another DAD for other reasons, which we might get into, but right now it's no coax, it's Cat5, and it's a single transmit and receive antenna per zone. Now we are getting a lot of questions about latency. So,
sure.
So let's dig in, because this is truly a choose your own adventure kind of path, where some elements of this system can tolerate higher latency, some need lower latency, and there's various trade-offs. So is there a place where people can, so they don't have to furiously take notes in our presentation, is there a chart that Sennheiser offers?
This is our LinkDesk software, and I have 3 packs, 3 SEKs connected to it. And what we can kind of step through is our first 11 audio link modes for the IEMs and for the mics. So we'll do that relatively quickly. So we'll start with stereo. There's 4 link modes available when we launch this. The lowest latency that we can get is 0.7 milliseconds for a digital stereo IEM, and the audio quality on this is equivalent to like a D6000, so like our flagship digital wireless.
Got it.
Sounds really good. And we can do 4 stereo links on that 6 megahertz carrier at 0.7 milliseconds. If we can handle 0.4 milliseconds more, 1.1 millisecond, we can get it down to 8 links, stereo links. And then we can do 16 stereo links at 1.6 milliseconds. We get into our link density mode at 2.7 milliseconds, and we could do 32. So it's, and you can kind of see as we move through these ranges here, you can see the range change, the audio quality change, the battery runtime change. It's all malleable depending on which transmission scheme we're using. So herein lies the challenge of like, oh, we have to make a document that shows all of this, because really it's like a spider graph that, different variables change depending on what mode you're using.
So I'm going to ask an example in my world of film and TV production. So let's just start with a situation where I have, let's say, 12 cast members that I need to mic up. And I have a general public IFB feed. I have a private to boom 1, private to boom 2. These are all mono feeds, so that helps.
Yep.
And then a script supervisor director feed.
So 3 privates and 1 general?
Yep. And 12 talent.
You can link up to 128 packs to the same feed, and you don't use any more resources for that. So,
amazing. Okay.
So for the general feed, and we'll switch this to mono, but for don't ask me again. For the general feed, we probably are going to leverage range for this.
Yep.
So this is going to be a higher range feed at 9.9 milliseconds. And we would use all of these feeds. And so we have a total of 4 or 5?
Total of 4 feeds going out.
4 feeds. We would use, let's see, so 32. We would still have, 28 mics at this range that you could do with the higher latency that you could stick in the same RF carrier. And then each base station you could do more. But yeah, say we build this out.
And I would probably, for my purposes, I would probably want to do lower latency on the talent
Mhm.
On the wireless microphone side of it. But yeah, the 9 milliseconds, because they're probably looking at delayed video anyways, might be okay. 9 milliseconds being roughly a third of a frame.
Yeah. If we go to like our these link density modes, you kind of lose some of the range. So here you have to deploy more antennas. But if we jump to the live, um, this one you get down to 1.6 milliseconds, and you could do 16 of those.
Mm-hmm.
You know,
Okay, good. Yeah.
so and then you kind of have this. It's almost like a bucket of capacity that you can kind of use depending on your needs and the tolerances of the talent, where you can if you really need to go down to 1 millisecond and have it be a uncompressed audio, that's going to use a lot more resources than these 6K quality modes, which have low latency values and good range, that kind of thing. So
That's great.
you set up your show how you need it. The base station can do 2 of these 6 megahertz carriers, and if you need to deploy another 6 megahertz carrier, you just stand up another antenna or another set of antennas, and you can do both.
Huh.
So it depends on how much you have to scale, how many channels you have going back and forth. But the IFBs or your IEMs in this scenario and the microphones are going to share those resources on the RF channel. The other thing that you could do that you cannot do, and that's kind of a very new thing with WMAS, is you can really leverage the time domain. So when I tell this pack to turn off, it stops transmitting. When it goes out of the range of the antennas, it stops transmitting, and it's bidirectional control that's in real time too. So this is maybe I could change it to a film. So if you had different scenes that you wanted to recall with the system, I could take resources from this pack and give it to that pack in real time.
Aha. Aha.
And that's over the control link. We're able to build, we call them productions, but you can recall scenes and give this actor's resources to that actor, and this actor shuts off.
So if you're wiring up casts that are in the wings, their pack would be off until it was needed, and then you can switch it instantly so that their pack becomes live.
Yep, you can automate that.
So Jonathan says a plug on. Absolutely. I imagine the marketing and product developers are well aware of that kind of feedback.
They're probably hanging out in the chat.
Good. Good. There you go.
If you say it, Marcus, that's helpful.
Yeah. And redundant lavs would be useful if there was a stereo transmitter version. Absolutely. That's very smart. And okay. And yes, a handheld version. Okay, all right. I think the other thing that struck me when you were speaking was there are times when you might want to add a second antenna to a zone, as I call it, where you're trying to improve your carrier to noise ratio.
Yep. Yeah, so you could do that to improve your carrier to noise ratio. You get more coverage. So the base station, if we look at the back, there are 4 antenna ports on a base station, and you can assign any of those ports to either of the 2 RF carriers that are available. So when you turn on a channel, you can say, my channel, I need to cover a large area, or I need to cover a hallway, 2 shooting rooms, and people are going to be traveling throughout a scene, and I need them to seamlessly walk between these antenna zones. You can assign that to an RF channel, or you can use those for redundancy as well. But the key is, as it is with narrowband, is you want to maintain your carrier to noise ratio and always have an antenna covering them. So in situations where you're operating on a low power DTV station, so say it's minus 90 dBm, you can use more antennas in that scenario to improve your carrier to noise ratio.
Got it.
You can use more antennas for if somebody damages a cable, you can have redundancy just so you make sure you get the take.
Understood.
And then the last thing it could do is a spectrum analyzer. You can throw up an antenna and kind of monitor your spectrum in real time as well. So,
and one antenna would be dedicated for the spectrum analysis purpose in this scenario.
yeah.
Okay.
So in our system, and this goes back to, we're not the only ones who do this, but we've always done this with D6000, and going back a long ways is applying narrowband filters to really eliminate adjacent noise in the system. So in the packs and in the DADs, there is a narrowband filter that locks on as soon as you assign an RF channel to it. So its window gets very narrow, even though the system can operate the entire UHF spectrum, 470 to 608 in the lower band, and in the duplex gap, it'll lock a filter around that. So if you want to have the constant scanning, you have to dedicate a DAD to that function.
Got it. Okay. But one thing that you said that really strikes a chord with me, and I'm workshopping this phrase, with wide bandwidth possibilities comes wide responsibility. And
yeah, I like it.
One of those is the filtering. And so, definitely on film and TV sets, I assume this is in other markets too. It seems to me the first AD always sees where the sound department has set up their antenna, and then that's where they stand with their 4-watt walkie-talkie and key into that system.
Yeah.
But my understanding is that these are very, very narrow band filters that really kind of lock on to just that 6 megahertz chunk.
Yeah, we have a couple layers of that going on, and if hopefully we get this out more, and there's not so many of them in the US yet, but soon later this year we'll have more in the field. But there's two layers of filtering. So we have those hardware filters that kind of lock around the carrier. This is kind of filter out the noise in a narrower slice. But then we also have in our baseband where if there's an interferer that you turn on top of the carrier, we are able to filter out up to 2 of those in the system. It won't show, it won't help the system that is on top of our carrier. So it'll still see that noise floor, but we are able to ignore up to 2 of them operating on top of us.
Let me reiterate that, because I've seen this in action at that presentation. But so you show up, and this goes to one of the questions that was about being a good neighbor. You show up, you do your scan, you find the 6 megahertz chunk with the lowest noise. Hopefully it's empty, but you can still tolerate a low power TV channel, and you fire up. Now, somebody else comes along, doesn't do that kind of diligence, and they just fire up their narrowband system in the middle of your 6 megahertz TV channel. The system, each element in the system will deploy a separate filter that specifically will narrow out that chunk.
Yeah, the system is able to ignore up to 2 of those. And so what we did in those demos is we go up and we touch the DAD with like a 25 milliwatt SKM 6000, and it's fine, that in that scenario.
And I really did see two systems, and then the third system you could start to see hear dropouts and stuff.
Yep.
Where it just couldn't deploy, couldn't tolerate that third carrier and deploy a filter.
And our OFDM scheme allows us to do that, over the 6 megahertz carrier, because it's wider. If a part of that spectrum is compromised, we're able to compensate for it. That's just kind of built into the design. Another thing, we're talking about being good stewards of it, is with the control that we have, and kind of that time domain is if I shut the carrier off. So when you first turn the system on, and this is the way it's designed, you have to activate the carrier. So you have to look at the spectrum, make the decision, I'm clean, I'm going to turn it on. And then everything links up. If you deactivate that RF channel, our carrier turns off and the packs turn off.
Got it.
So everything stops and starts, and you have total control over that. On a narrowband system where it's more of a one-way path and this thing is kind of unaware, if I forget my pack is on and then I walk into another studio, I can cause interference, kind of like the person you talked about who came into the scenario.
Mm-hmm.
With this, I can control that. And this, it also, once it loses its range of a DAD that's on its channel, it automatically stops transmitting. Mm-hmm. So it's in that case, we've put a lot of thought process, knowing that it's a wider carrier, into being good stewards. I like that phrase. Yeah, that's what we're trying to do.
I like that too. I want to echo and acknowledge Michael Wynn's question. Are there plans in the works to expand the technology to film and TV with DC powered systems? I noticed the redundant AC on the back. We've seen other instances where one of those redundant ACs is turned into a 4-pin DC input. And I would like to echo that request. And then SuperSlot receivers, and is there a timeline?
Okay. So we have heard the DC request for a base station. Mm-hmm. So that's kind of on like the bigger, request list. I think because we last made a SuperSlot receiver with the EK6042. So we have a 2-channel digital SuperSlot receiver that we still make. It's great. It can do analog and digital and all of our, companders and codecs. But what we had been getting, and this is where we need your help. But I think what we hear is people are starting to go to smaller format cameras, mm-hmm. and things like that. So if a SuperSlot is required, I guess we'd probably see that more in a bag.
Yeah, and I think there's been a couple of questions about bag use too. Yeah. So one of the things, and this is neither a strength nor a weakness of the system, it just is what it is, mm-hmm. is that these components only operate when they're in range of a DAD. So in specific terms, if Michael wanted to have a wireless feed to a camera, mm-hmm. you could repurpose one of the packs to be just a receiver and, go stereo mini out to a pair of XLRs. And mm-hmm. as long as it was in range, I know it's not the same thing, and it's not what you're asking specifically, but I think that's one case where I might use it, where I had to send multiple feeds to various cameras that were covering, I'm thinking reality show style.
So a portable base station that lives in a bag.
Well, what I'm suggesting in my example is I would take the pack in your hand, the SK pack, is that?
Yeah.
And I would put it on the camera as a receiver. And just do the audio out. I think Michael is looking for a standalone portable receiver, and I think part of it is the regulations of WMAS specify a minimum channel density.
Mm-hmm. Yeah, so it would have to have the ability to do per 6 megahertz up to 5 outputs. So we would have to have some kind of a adapter for more than this. I mean, this system has the ability to do that fairly easily, but if we adapt it to like a portable something, we'd have to think about that. It would be a multi-channel system versus less than that. You probably would be looking at a narrowband system.
Here's since you mentioned there might be some Sennheiser folks listening, here's my pitch.
Yeah, perfect.
Is that the pack, any pack can have multiple firmwares that can reconfigure an SDR. I assume that's some kind of SDR technology, mm-hmm. so that I can reconfigure it to be 6000 compatible with a push of a virtual button, and that way the specific use case scenario I'm thinking of is in a reality show when the contestants need to leave the studio and go shopping. I don't have to repack them.
Gotcha.
I can just say, hey, you're a 6000 compatible transmitter now, and it's going to get paired to that 6000 receiver. That's a slot receiver. I realize it's super easy for me to say stuff like that, but that's that's one idea. And then the other thing is they are 3-pin LEMO connectors, so if I had to repack them, it's not the worst.
Yep. I would say that one we were probably a ways out. But I think what we need to do is, and really how this project is set up is we need to hear that and capture those workflows so we can create new products that can accommodate that. Right now we're kind of set, like you said, you would have to use a DAD, you'd have to use a base station, and everything is kind of pointing up and down to the DAD. There's with our what we have here, there's not a quick changeover from a narrowband 6K transmitter to the WMAS carrier. It's a different.
A couple of other questions, and yeah, I love the questions that are coming. So please, as long as we're not boring you, please ask the questions. Is there no RF penalty for having an RX so close to a TX in the pack? Can I answer this question? Or attempt, and then you correct me if I get it wrong.
Great. Yeah.
So it's data. I mean, they're all just transceivers. So at that point, it's not like one slot is transmitting, one slot is receiving in the pack. It's just getting the data and exchanging data with the DAD and then onto the base station. So there literally is no penalty because it was designed from the ground up to do that.
That's exactly right. It uses TDMA, which is, the frame has 128 time slots, and the IEM information that is coming in and the microphone information that's going out, they're in different parts of the frame. So it's not happening at the same time. It's really fast. Mm-hmm. And everything is well isolated from each other in the design, so there is no penalty, and you explained it perfect. So TDMA scheme and using the time slot, so it's really all of those audio links are being chopped up over those 128 time slots, and that's how we're able to do it.
Andrew asks an interesting question, and when I read it, I think I misunderstood it. Can you change the bell pack settings, mic gain, latency, etc.? And we should talk about mic gain in a second from the 1RU transceiver. And at first I thought, oh, well, Chris is showing it, but I thought maybe Andrew is talking about without needing a program and doing it directly from the 1RU if you didn't have a computer or your computer crashed.
That could be possible. I think when we launch this, it's either going to be via a web app, which is talking to the base station, so we can navigate to the base station, and we'll launch it with the software. We're launching it potentially with 3 softwares when it ships. So the first one would be LinkDesk. This would be your configuration, your firmware updates. You could do everything in here, but this runs on a PC or a Mac. Mm-hmm. We also have, if you navigate to the base station and you put a router on it, potentially if you want to do things wirelessly through an iPad or something like that, Spectera Control. And when LinkDesk is running, this kind of defeats itself. So it's an either or, but multiple devices can connect to this. Really what happened here is, this was used as a testing tool, and it got good enough that we're going to release it with the product because we were all using it. We're like, it's pretty nice, so we'll keep it in there. So
I love that. I think that's referred to as eating your own dog food. Is the phrase.
That's I've never heard that. That is awesome. And then we recently developed a close partnership with SoundBase, and they already control with SoundBase Pro. All of our products as well as other manufacturers. So this will slot in with the sound control protocol that we use. It's a JSON-based protocol. Mm-hmm. It's going to work with that too. So those will be the 3 ways you can control it. I think our thought process, because it is 1RU, if I go back to the thing, it's like an OLED screen with a knob and a button. Mm-hmm. This is fairly sparse. I think our current thought process is that would be a lot to do if you were changing, levels and audio links on that knob.
Right.
There, you can do things like turn the RF channel off if you had to defeat the system, like kill or like factory reboot it, that kind of stuff. You can do that from the knob. But critical things like adjusting the gain of the pack, where we're looking at a meter and a slider, and we're trying to do this in real time, or like the low cut, and this is adjusting in the pack in real time when I do this as part of the control link, or the headphone volume of somebody's IFBs, or setting the stops on it, like the high and the low. We feel that that has to be done with software and not a tiny screen.
Got it. Makes total sense. Martin asks, is the control of packs 100% reliable when in range? So, I mean, yes is the...
It's part of the link. Yeah. So the control information is always going back and forth, and it's always checking the values too. So, before, with the one-way system, the way we've approached it, and people have done other things, but we've always approached it, at first with infrared links, where you kind of held that up. And now we have Bluetooth Low Energy, which is a separate frequency transmitting, at the same time. Other people will stand up a separate access point network and things like that to control it. This is just part of the link, and it's always on. So the control is bidirectional, and the monitoring is always bidirectional when the pack's in range. We should go through the three components.
Great. Okay, good.
A little more in detail. So the body pack, we talked about that. One thing we didn't talk about is that the DADs and the SEKs are going to come in two frequency ranges. So we mostly landed on UHF, which is going to be 470 to 608. And then that unlicensed part of the duplex gap that we can use with it, that'll be UHF. And then we're going to have a 1 gig 4 variation. So this is in the AFTRAC. This is going to be in the 1G4 range, and we have about 90 megahertz there that is currently used for flight training and flight testing, and it's managed by an organization called the AFTRAC, or AFTRCC. They are looking to lease this spectrum to low impact partners, which we can go up to 100 milliwatts. So for them, we're pretty low impact.
Yes.
And you would be able to lease it for a big event. If you had the Super Bowl, or the Olympics, or the World Cup, or whatever's coming here, that we have 1 million channels going on. There's 90 megahertz where you could park that 6 megahertz somewhere in there, and it's your spectrum for that geolocation for that time. So we'll have both options for that. The antenna gets really tiny when we do 1G4, and then also we'll look at the DAD. It's a tiny DAD, and both of those are developed for this system. So we'll have those options when you're looking, what am I going to do with my 6 megahertz when it's the Super Bowl? AFTRAC is a good option for that.
So that's a separate SKU, meaning that's a separate product entirely.
The base station can do both. So the base station can do a UHF and an AFTRAC at the same time if you want to, like on its two carriers.
Yeah.
But the filter sets in them and the antenna tuning. So we'll go to the DAD. This is the tiny AFTRAC antenna here. Those are designed for that frequency range. So you have to have different AFTRAC or 1G4 versions of the DAD and the SEK in order for that to work. But the base station can handle all of that. And it's one of those things where, we've been nicked several times by the frequency changing, where if we could develop an ecosystem where we're really just kind of changing out endpoints, if we have to deploy another frequency range, we can do that with this. Because the base station doesn't have a bunch of RF components in there. It's just a super processor.
Yeah. And okay. Yeah. That's fascinating. And you are fresh from an FCC conference.
And last week.
And so are these rules around AFTRAC This is the first time that I've heard it referred to as leasing the spectrum. I've often heard it where it required more formal, sort of permitting process.
Yep.
Did that come out of this FCC conference?
So it's pending, and that handoff doesn't exist. So the hardware, as you could kind of see in the pictures, it's relatively finished hardware at this point that we'll be able to deploy. What the handoff will be is you will request the spectrum from the AFTRAC. Right now, this is very manual, and you would submit via software your location, so your geolocation and the time of your event, and they will give you an encrypted key, which unlocks your system to transmit. So that whole thing is still being worked out. But there are other systems that operate in this and go through that, like you said, the manual permitting process.
Got it.
The hope is that will become a little more seamless and a little more user friendly in the future. So that's what they're working
on. Lovely. All right. It sounds similar to white space device kind of registration problems and questions, plus an encryption key. But cool. That's cool news, and that's good to hear. Okay, so I also want to say want to get to some questions just generally before we wrap up. My wish list for a future portable base station. This is Carlos. A 1U half rack size with minimum 8 TX capacity, 9 to 18 volt DC, fanless, Dante and or AES with bag friendly DADs. Yeah, bring it.
Bag friendly dads.
Yeah. I like that. All right.
I'm taking notes. I know, like if John Zambrano's on there too, like check me when we're done.
and Victor also has a similar request.
Okay, good.
Are there any chance in the future you make a smaller, cheaper 16-channel half rack? Very good. And then Yvonne, sorry if I'm mispronouncing your name, asks a question. Can we achieve excellent audio quality, the lowest latency, excellent range, long battery run times at the same time? And what would the spectrum density be? And that's actually an interesting thing. It's the first time I've thought about what battery life affects, how battery life is affected by the different modes.
And we didn't completely talk about the battery either. We didn't get to that. And I think this is more fun, honestly, than me PowerPointing you to death.
Me
so
too.
This is way better. The battery that we're using is the BA70. So we're standardizing on a battery. This is a Sennheiser initiative that we're not going to make really cool bespoke batteries for one device that only works with this device, even though it's really beautiful and locks in. This is a manufacturing and supply chain challenge if we do this. So we're standardizing with this system, and on hopefully most things going forward, the BA70 battery, which is 6 hours with Spectera. You cannot use this with AA's in a pinch. There's too much going on in here. And then we're working on an XP version of that, which will have longer battery life. So this is a $50 battery.
And nice. And 6 hours regardless of any of the modes that we spoke about?
So you get more battery range with some modes. That's a slider there. So we're really basing this on IEM use, so stereo IEM use, where there's some higher impedance headphones that are really driving this.
Got it.
So that's kind of the benchmark. And then we're looking at having an XP version of the battery that will give you longer life, but still be the same format and work with all of our products. So we won't develop just a Spectera battery.
So is 6 hours the worst case scenario?
I bet if you were really driving this with some high impedance headphones, you could probably get it down to 5.5 hours.
Okay.
That kind of thing.
Yeah, good. Has there been testing done to see what body absorption does to this wide of a carrier?
We really wanted to have a good handle on this before we were showing it at ISE. So this is going to be before that we had it at a couple trade shows in a secret room, which was pretty off on its own because we were trying to be sneaky or secretive, I guess is the word. We didn't want to launch it yet. So before we took it out on the ISE floor, we were really beating it up and doing tests with the different modes. And, our definition of a torture test is to, take the antenna and detune it, put it against your skin, put it under your arm against your skin, that kind of stuff, and see what kind of range versus, us walking around like the Statue of Liberty, which isn't realistic, right?
Right.
Your range varies depending on the mode. So we have longer range modes, which are, and also the live low latency modes are get a really good range. We would compare these to, narrowband microphone systems. When we go into the lower or the higher density modes, you'll see that slider, and the way we represent it, you'll see the slider for range go down. So when you have those higher density modes, you may need to use more antennas. And how you would deploy that, you would spin out another category cable and another antenna in order to get more coverage, and that gives you more channel density in a space. So it's another thing that we need to figure out how to do a configurator or something like that to say, okay, my goal is to have the most range, and then we recommend the modes you use,
right?
That kind of thing.
Yep.
But it really varies depending on the audio link mode that you're using. We kind of feel after beating it up, the modes when you're using two antennas, it's very stable, even though in those link density modes. If you're really set on using one antenna, you would want to use kind of the longer range modes, those kind of things, if you can do that.
Got it. Gianti, I apologize for mispronouncing your name. Will the system be compatible with different brands like Sennheiser and Shure mixed units, but both WMAS? I think we've covered that a little bit in the sense that it is Sennheiser's WMAS implementation is proprietary to Sennheiser's WMAS.
We did have an exciting thing, and while it's not the system, but our partnership with SoundBase, so SoundBase users, I think we want to reiterate that we're keeping that as pretty manufacturer agnostic. So if on the control side, we have that, that's something that works across all brands, and we're really excited to partner with them.
People that don't know SoundBase, it is RF coordination, RF software for RF coordination, monitoring, and control of across, as you just said, various manufacturers. I do want to talk about the gozintas and gozatas on the back of the base, because it's I think it's cool. You have all the DAD outputs, but it's like out of the box. It's got redundant Dante. Do I see some? I see a Cascade port, and I see a MADI option. Is that right?
Yep. There is no analog I/O on this, so you'll need to run Dante or MADI to get the audio out of it. That helps us get it down to 1 RU, but also our goal was to keep it as redundant as a redundant console. We've kind of done EM1046 and our 9000 series are these chassis-based systems where you have a lot of eggs in one basket. So we know that we need to be redundant, and so we kind of filled the space with redundant power, redundant antennas, redundant Dante, redundant MADI. All of the audio interfaces have their own sample rate converter on them. So if you had, this might happen more, it would happen in live broadcast. If you wanted to get the speed of the console down by running it MADI at 96K, but then you had a broader Dante network that you were running at 48, you can do that.
That's great.
That's no problem. And then the control, if you lose control, the system continues to operate until you get control back. So that's how that works. It's not, you're just not going to change the settings if you lose the control network, except for the front panel, which we talked about before.
Right.
It probably won't have all the settings in there. The Cascade port is coming in the future. So these are going to use SFPs. Right now, when we launch this, you have 4 antenna ports. You may need more antenna ports. You may need more RF carriers, or you may need more than 32 in and 32 out. The Cascade port is there to expand that. We think that there will be a cap to this, so probably 8 devices, and then we're working to how far we can push that as far as, how many antenna zones can we get on one carrier, how many RF channels can go across the boxes, but also expanding the audio I/O will be a big part of that Cascade port as well.
Got it.
So that's coming soon. The other one that is on the board for kind of a low hanging fruit, but it's really not that easy. I think we're learning. We feel like it is even on our team. Is we just merging technologies is part of Sennheiser now. It's part of the Sennheiser family, and it is one of the largest manufacturers of AES-67 chips. So working into SMPTE 2110 workflows and AES-67, there could be a seamless transition to putting a Z-Man chip in there for AES-67 and SMPTE 2110 workflows.
Nice.
So I think that's in the plans too. How long that will take, I don't know. But we are a chip manufacturer now. So.
And just some cleanup bits of information about deploying DADs. So it is Cat5 cable.
Yep.
It's Ethernet cable, but it is not something that you could put through a switch or something like that. It's right now point to point.
Correct.
But you did mention media converters that you can use it over fiber if you had to.
Yep. Thank you for keeping me honest with that. They are home runs. We have stripped the Ethernet layers off to get it fast enough to get that latency down where we can do a sub-millisecond stereo IM. We can't do that if it's got the switching layer on there. So it's layer 1. So we're testing layer 1 fiber media converters. I have a couple here that a manufacturer sent me, and I took it to 1,000-foot spool of single mode fiber, and that worked out pretty well. I think our goal is to find the limits of that. So we're going to need some help finding a shop that's got a kilometer of fiber that we can link together and see how far we could push it. And then also create a list of approved media converters that work with it. Likely they're going to have to be layer 1 media converters. So if you find one on Amazon or something that, looks good and it's $120 or something like that, be very careful to make sure that it's layer 1.
Right.
I think we will give you a tested list of ones that work. The one thing with fiber, when we extend it, and we think we can extend it for kilometers that way with fiber to cover a very large area, or use infrastructure within a sports facility, something like that, be able to patch in.
Dry patch.
Yeah.
Once
we get that tested, you will need to use a PoE injector because we lose the power once we hit the fiber. So the base station is providing power to the DADs. The limit to the category cable length is 100 meters. So it's the same as the Ethernet standard. It's just the protocol is layer 1 because we had to make it faster.
Got it. And so Justin, shout out to Justin Herminghaus. That answers his first question. What are the cable limitations? Cool. And then can one space support more than one zone or space?
Yeah. One space could theoretically support up to 4 zones with 4 antennas. And you could assign that to one RF channel.
Right.
And as people move between antennas, it's seamless. And it's all time and phase coherent.
Right.
So when we talk about those stereo miking applications that you talked about before, if we're going to, put this on an MS rig or something, or dual MS or something cool like that, we'll be able to do that where that was a little more difficult before.
Copy that. And also, unlike a penalty where if you have multiple transmit antennas, in a more traditional system, there's no, fading or anything like that. There's no cancellation. You're not worried about overlap of coverage in that sense. It all works together.
Yeah. One of, I think on the TA team, one of our favorite things to do is do multi-zone antenna system design, because we get to get all these custom amplifiers and Usually they're pretty complicated, and we can kind of bury our head in the loss calculations
Yeah.
and like build things. Now it's kind of just run a category cable, and on the transmit side, or so the IFB side or IM side, that becomes a lot easier now.
Yeah.
Because all of the antennas are working in concert with each other, and you can just move in and out of the zones.
And that same, well, correct. This is a question, so correct me if I'm wrong. That same kind of data, at sort of combining data from each DAD on the receive side, does that also work on the IAM side where the pack is receiving multiple points of data from the DAD transmitting to it?
Yeah. So the pack on the receive side, as it moves between antennas, and there's multiple antennas in the same space.
Correct.
If you put them all four next to each other, that's fine.
Right.
So say you wanted redundant antennas and you mount them on a stand with the T-bar, that's fine.
Got it.
Like and that works for the IFB or the IM side too.
Okay, and Norm, what do you do if you show up to a venue and your scan shows you don't have enough carrier width to accommodate a wide carrier? So one thing I'd reiterate to Norm is we are limited in this system, and this is by FCC rules, to the channel grid, the TV channel grid. So if you get half of one free and half of another free, you don't get to take advantage of that.
Mm-hmm. Correct.
But to Norm's question, is, what happens if there's no quote unquote clear chunk of 6 megahertz?
Well, it needs 6 megahertz. So that's a fact. One of the things that we'll continue to do is make, digital 6000 and EWDX and narrowband systems that don't generate intermodulation. So now that we have this in our other narrowband systems, we're able to equidistantly space them. But what I would do from a workflow when you go to a site to find 6 megahertz is, do the scan. If the 470 to 608 megahertz is completely full, the system is able to operate in the duplex gap on the unlicensed spectrum, which is 657 to 663.
Mm-hmm.
And in every market, that is pretty open unless you have another PMSC or production system operating on it. So that's a good place to start if you are completely blocked up in the lower 470 to 608. From there, you would look at low power DTV stations, so something that is minus 90, something like that. And in that case, you may have to use more antennas in order to get the carrier to noise ratio that you need.
Got it.
Or in bigger events, we have the 1 gig 4 space, which has that 90 megahertz open that you could lease, but that is probably going to be used for more event style things versus a broadcast studio or something like that.
Right.
Yep. But it doesn't, the channel itself, if we put it up on an analyzer, it doesn't have, big slopes that expand into the other channel. It's very clean. You can operate narrowband carriers adjacent to it.
Uh-huh.
It's okay. That's fine.
And that goes to the good steward question as well.
Mm-hmm.
This is truly the next generation of wireless that we are seeing. And, I know for Gotham's core customers, it may not tick every box that we need right now. But I think it's such an important technology for us to start to think about. And, already in the comments, you can see people thinking about how they would use it. But it really is very special. Keep the comments coming, even though we won't be live, because as you said, Sennheiser folks will be monitoring the chat. And I really I have to thank you. Is there anything you'd want to add before we sign off?
If you want to learn more about it, obviously, I don't know if there's a way in the chat for our BDMs. I know they're kind of in there watching to see what happens today. If they could put their emails and contact information. Otherwise, I'm going to put a QR code up on the screen, and you can scan this QR code. It's going to take you to our page with the documents that we have. Mm-hmm. I think every one of these conversations we learn about a configuration tool or a document that we need to make. And so we're kind of frantically working on those. But We're really excited to start talking about this, to get this in your shops. I think we're at this point where we don't need the STAs anymore, where we can go and kind of put it on a bench and like let people beat it up. And that's going to be a lot of fun. And I really think, the majority of 2025, that's going to be most of our time in the application engineering side. Also, we plan to start shipping this mid next year. So
Yes.
when the systems do start shipping, and when they're out in the wild, I think we want to be a part of that. So like that two-way communication, if you're deploying this, we want to make sure that these first ones, because it is a new thing, that you kind of have that, constant support because you're trying something new,
Yes,
so
for
so
sure.
think about that. And I would say that's about it. I really appreciate the time. This is way more fun than me standing up in front of a bunch of people and doing a PowerPoint. So I will do this any day.
Agreed. Awesome. We will offline talk about open house and where people might get to really try this out for themselves. That's what it was a big deal for me to be able to try it out.
Mm-hmm.
Yeah, and thank you so much.
Yeah,
Thank you.
thank you, Peter.
You
This is
bet.
great.
Thanks for watching, everybody. As always, if you have questions or you have ideas for future live streams, info@gothamsound.com. And thank you, Jared. Thank you, Nate, for your efforts controlling this stream. And take care, everybody.
Bye.